Hello everybody, am I audible to you? Am I audible, guys? Who is watching me live? Anushka, Muhammad, or anybody else is watching me live? Yes or no? Please let me know. Please let me know, guys, that you are watching me. I hope that I am audible to you. Yeah, Anushka, good evening. Am I audible to you? Yes, Anushka, am I audible to you? Okay. So, okay, guys. So, good evening, all of you guys. I hope that you are doing good. And good evening, Muhammad. Everybody, good evening. Please let me know that who is watching me live. I hope that my voice is clear to you and video is also very clear to you, right? So let's quickly go through whatever we discussed in the last class. Okay. Whatever we discussed in the last class, just let's discuss that part. That will move towards the next part. Okay. So very quickly we have covered the thermodynamics third law, right? And after that, my next chapter, or you can say the last chapter, is the properties of the pure substance. Okay, properties of the pure substance. So first we discuss the properties, what is the pure substance and what is the criteria for the pure substance, right? And in this chapter, basically we have studied the behavior of the water, right? Behavior of the water basically we check in this chapter. After that, we just discuss about the phases of the pure substance. There are three phases. Okay, can you tell me that how we can distinguish the two phases? How we can distinguish the two phases? Let's suppose you have a liquid and gas in a single container, or you can say in the confined volume. So is there anything which is basically separate both the phases? बोलिए. Is there anything? Okay. See, yeah, definitely there is a distinct molecular arrangement is there, but if anybody is saying that, okay, just let me know that how you separate, how do you see the separation between the two phases? Let's suppose you have the liquid and the gaseous phase. The inter you can say the layer, interface layer between them. That is a, you can say that the imaginary layer which is in between the liquid and the gas phase. That boundary is basically separating the two phases. Okay, compressed liquid and saturated liquid. So the compressed liquid definition is very simple. See, the definition of the compressed liquid or subcooled liquid is depend upon what, guys? It is depend upon that you can say that what is the state of that water. Or this water is going to be in the converted into the phase, or this phase is at the verge of conversion. Yes or no? Okay. So the very important line, the underline is the liquid which is not about to vaporize, right? That it doesn't mean that in this state, if we give some heat to that liquid and it suddenly gets converted into the vapor. No, it is not about to vaporize. It requires a lot of energy to convert it to the vapors. That state is called compressed liquid. Here it is the T equal to 20 degrees Celsius, pressure is equal to 1 atm, right? The pressure and temperature can be anything for the compressed liquid, guys. Okay, it is clear to you. And so this is my state 1. Saturated liquid means that enough amount of heat this compressed liquid can basically absorb. Now the further heat can cause the state phase conversion. That is saturated liquid, right? We are giving heat, and now the enough amount of heat is absorbed by the liquid. Now the further heat will cause the phase conversion, right? So for the water specific, that temperature reaches at the pressure 1 atm. This is important because the pressure value change, then temperature values also change. We will talk about it. Okay. So when the at 1 atm, if my liquid is reach up to the 100 degrees Celsius, then further heat can cause its phase change, guys. Okay. Saturated vapors, again it is very simple. Saturated vapor, first of all, the word vapor itself and a word saturated, it means that any loss of the heat can cause the condensation of that vapor. Means the vapor is at the verge of the state. Okay. Superheated vapor means that the enough amount of heat is basically are there to that of vapor. Okay. Yeah, this is my important TV diagram which we basically discussed earlier. So I'll repeat this diagram again because this diagram is very important for us, and we will discuss all these things in this lecture. This is my TV diagram. Okay, this is my TV diagram. Now this is my state 1. Please guys pay attention here. This is my state 1. The temperature is my 20 degrees Celsius. Whatever we are doing this experiment or whatever we are writing at 1 atm pressure. Means pressure will be constant. We are not going to change the pressure. Okay, so there is no need to say again and again 1 atm, 1 atm, 1 atm. It is understood. It is at 180. So temperature of the water is 20 degrees Celsius. Okay, there is no problem. There is no problem at all. It is compressed liquid. We are giving heat, we are giving heat, we are giving heat. What will happen? Water starts to expand because we are giving heat. And at a certain point of time, my water reaches up to the 100 degrees Celsius. But my dear friends, 100 degrees Celsius, but what is the state of the liquid? What is the state of the water? That state of the water is still liquid. Still liquid. But that liquid is called, that state is called saturated liquid. Means liquid is at the saturation level. Further amount of heat if we are giving, then that heat is utilizing to change the phase of that liquid. So from 1 to 2, what will happen? Temperature will increase. And due to the expansion, my specific volume is also increased. The heat which is utilizing to change the temperature, that heat is called sensible heat, guys. Drop a message if you are not able to understand it, please. So 1 to 2, there is an increment in the temperature, there is an increment in the volume. That heat is called sensible. After the stage 2, so what is the point 2, guys? What is the point 2? Point 2 is representing the saturated liquid. After the point 2, what will happen? Now the further, if we give the further amount of heat, then that heat is utilizing to convert the phase. Now the liquid is being converted into the vapors. It means the vapor volume will increase, liquid volume will decrease. Yes or no? Okay. So from 2 to 3 and from 3 to 4, what is this? From 2 to 4, what is the state? This is saturated mixture. Saturated mixture means saturated liquid plus saturated vapor. At the stage 4, what is the stage? At this 4, you can say every single drop of the liquid gets converted into the vapor, guys. At the stage 4. Am I clear with this? So this region is showing mixture of liquid and the vapor, or you can say mixture of the saturated liquid and the vapor. And point 4 suggests the, what is that? At the point 4, this is the, what is the 4th point? This is my 100 degrees Celsius saturated vapor. Because during the phase, there is no change in the temperature at all. So the heat which is utilizing to convert the phase of the particular substance, that heat is called latent heat, or it's also called hidden heat. Or it's also called hidden heat. If I'll ask a question to you, please tell me. Both of you, please tell me. 100 degrees Celsius water, liquid, is dangerous, or 100 degrees Celsius steam is dangerous? Please tell me. Which one is dangerous? If your answer is this, type W. If your answer is this, type S. Please. Steam. Very good, steam. Why? Because the water has only the sensible heat, but the steam has the sensible heat plus latent heat. So the steam has the more heat as compared to the liquid state. Very good. Now, so the stage 4 is called saturated vapor. Why it is called saturated vapor? Because if small amount of heat loss causes the condensation process, right? Small amount of heat loss results the condensation process. Okay, yeah. Now this is my 100 degrees Celsius saturated vapor. If you further give heat to the system, now the vapor is that now phase will not change, because only these are the phase. They're liquid into solid, sorry, liquid into steam, or you can say the vapor. That's it. Now further your phase will not change, but yeah, temperature will change, right? Temperature will change. And after the 100 degrees Celsius, like at 105, 1010, 150, 300, at this temperature, this vapor is called superheated vapor. Now again, what is this heat? This is also called sensible heat. Please tell me that these things are clear to you or not. After that, I'll move ahead. After that, I'll move ahead. Please tell me, guys. Please tell me. It is clear to you or not. Okay. Now, a diagram is also there, which I want to discuss with you. So, see, this diagram is enough for us. Whatever further we plot the diagram, we plot the diagram of this kind of diagram we will plot further. Okay, but to understand overall behavior of the water, we can also take this advantage, because we have the knowledge about the water. Let's understand the behavior of the water even at the negative temperature, right? Because the water shows a very slightly different behavior as compared to the other liquids. That's why I'll explain this diagram. Okay, so again, I'm plotting the diagram temperature versus specific volume, means TV diagram for the water. That is my TV diagram for the water. Okay, our task is guys, our task is to, let's suppose we have a ice at the temperature minus 10 degrees Celsius, and I want to give heat to this ice, and I want to reach this temperature above the 100 degrees Celsius. Let's suppose I want to convert this into the superheated vapor at 120 degrees Celsius. Let's suppose 120 degrees Celsius, right? Okay. So very simple. Let's suppose there are certain values. Let's suppose it is my 4.4 degrees Celsius temperature at the axis is degrees Celsius, right? And let's suppose it is my 100 degrees Celsius mark. Okay, let's suppose it is my 0 degrees Celsius, and below this it is negative, right? Initially, what is the state of my ice? It is my, you can say that what is the state of the water? Water is my ice, and which is at the minus 10 degrees Celsius. Okay, great. So let's suppose that my water is minus 10 degrees Celsius, means it is my ice, right? I want to ask a question to you guys. I want to ask a question to you, that tell me one thing, that when you freeze something, okay, tell me one thing, that if you will heat up something, most of the material, what is the status of most of the material? It will expand or it will contract or anything else? Batao. Bolo. Please tell me that by hitting something, what is the common behavior of the materials, or by cooling, what is the common behavior of the materials, or you can say the liquids? Great. Most of the liquid, if we'll heat it, then it is going to be expand. Then if we cool it, then it is going to be contract. And this is the common behavior of the general of the, you can say, in general terms we can say, right? Okay. See, so guys, let's suppose minus 10 degrees Celsius is my ice, and my ice is at minus 10 degrees Celsius, and we have to reach up to 0 degrees Celsius, right? So first of all, this minus 10 degrees Celsius reach up to the 0 degrees Celsius. Okay, this is my 0 degrees Celsius. What is my 0 degrees Celsius ice? Okay, great. Now see, now if we will further give heat to it, what is the common behavior? Common behavior of the most of the liquid is they basically going to expand. But a very interesting behavior of the water is that it basically going to contract. It basically going to contract, guys. Right? What is the density? Density is basically mass upon volume. And from 0 to 4.4 degrees Celsius, when your ice reaches to 4.4 degrees Celsius, then what will happen? What will happen? Just please try to understand it, and I'll explain it. First, let me explain this thing, and further, if you have any problem, you can ask anything. Okay, I'm open to tell you any doubt. Right? Just try to understand this diagram. That's it, nothing else, so that you can have the best knowledge to understand the behavior of the water. What is this minus 10 degrees Celsius? And if I'll give heat to it, then it will going to expand and its temperature will increase. Yeah, for sure. It is the normal behavior. Yeah. At this point, it is my 0 degrees Celsius ice. Now further, if I'll give heat to this ice, what will happen? What will happen? Right? So I think I don't have to wait for your answer. You know that 0 degrees Celsius ice, if further we give heat to it, then it is converted into the 0 degrees Celsius water. Okay? It is converted into the 0 degrees Celsius water. So this is my 0 degrees Celsius water. So you will ask, sir, why 0 degrees Celsius? Because during the phase change, there is no change in the temperature, right? Okay. Now this is my water. Now further, if you are giving heat to it, then what will happen? What will happen? The specific volume will decrease actually. The specific volume will decrease actually. Now this is your 4.4. At the 4.4 degrees Celsius, this is the minimum volume of the water. This is the minimum volume of the water. And minimum volume means maximum density. Minimum volume means maximum density. It is clear to you, right? So whatever you will see the data in fluid mechanics or anything, that the density of the water is 1000 kg per meter cube, that is basically at the 4.4 degrees Celsius, and this is the maximum value of the density of the water, right? Density is the matter of temperature. According to the temperature or due to the temperature variation, my density can be varied. But whatever the data you see in the questions in the fluid mechanics or anywhere in the heat transfer also, and they are giving you the value of rho is equal to 1000 kg per meter cube, that is basically value at the 4.4 degrees Celsius. I hope that I am very clear to you. So this behavior is very strange, which is shown by the what? Which is shown by the, yeah, it is clear to you or not, right? Further, if you will give the heat to it, then the normal behavior you can see. Further, if you will give the heat to it, then as you know that water is basically going to expand. You can say that volume, specific volume will increase, and it can reach up to the 100 degrees Celsius water. Please let me know that this up to this point it is clear to you or not. So it is my 100 degrees Celsius water. It's liquid. Okay, it is clear to you or not? It is clear to you or not? Further, if you will give it to the heat to, if you will give heat to it, then what will happen? Phase change will occur at the constant temperature. This is my 100 degree steam, and further if you give to the heat to it, then it is my temperature will basically increase, and if you want to reach up to the 120 degrees Celsius, then we can achieve this temperature. Okay, that is clear to you. If we'll talk about the heats, then guys, this is my sensible heat. Right, this is my latent heat, this is my sensible heat, this is my sensible heat, this is my latent heat, and this is also sensible heat. You can't understand the contract part? Why? I don't. क्यों नहीं समझ में आया आपको? Why बेटा? Why? Okay, tell me one thing. Tell me one thing. कभी तो लाइफ में in your lifespan, have you removed the ice cube from the ice tray? Have you ever removed the ice cubes from the tray? Do you feel that it's very difficult to remove the ice cubes from that tray? Is that contract because of density? No, there is no relation of the density. That is the, actually I explained the maximum density because, or you can say due to the contraction. Okay, just hold on, I'll explain it. Yeah, Anushka, please tell me, are you getting my point or not? Please बताएं मुझे, आपको समझ में आ गया? See, I'm damn sure that you experienced in your life that when we remove the ice cubes, then it is difficult to remove that ice cubes from the tray, because when, let's suppose, see, just try to understand it. First of all, this is the unusual behavior of the water. This is the unusual behavior of the water. Unusual behavior means that no every liquid showing this behavior. General behavior is By heating, expansion will occur. By you can say that by you can say that if we call something, then it will contract. If we'll give heat, expand. If we will cooling, yeah, cooling is the right word. So if we doing cooling for any substance, it for liquid, it will contract. This is the general case, right? Water is also following this behavior up. Just accept this part. Accept this part. In this part, it is showing a very unusual behavior, right? And due to this behavior, I'll explain this. Due to this behavior, the aquatic life is, you can say, surviving on the you can say that on this earth, or you can say on this ocean. Due to this unusual behavior, I'll explain it further, right? Why I am saying that it is the unusual behavior, because giving heat, expansion has to be occur. By cooling, contraction will have to occur. But here, from this point, if I give heat, it will expand, temperature will increase. Good. Here also, I'm giving heat, it is basically expand, and temperature will also increase, right? But from this point, this is the unusual behavior which is shown by the water, that upon heating, see, temperature is increasing from 0 degrees Celsius to 4.4 degrees Celsius. What is the meaning? That we are giving heat to it, right? But giving heat means expansion, but here we can see that it is the contraction, because volume is continuously decreasing. Arrow sign is from here to here. Yes or no? So this is the unusual behavior of the water. Up to 4.4, this is the behavior. After that, the behavior is normal, right? So density तो मैंने calculate किया 4.4. Water is going from 0 degrees Celsius to 4.4. It will contract. It will contract. It will contract. It will contract. It means that we can say that at 4.4 degrees Celsius, the volume of the water is minimum. If the volume of the water is minimum, I can say that density of the water is the maximum at the 4.4 degrees Celsius. Why I'm saying that it is difficult to remove the ice into the tray, because it is in the ice. What is the process? Processes of the cooling. Cooling means contraction, but here the process is different in this region. So when you coming from 4.4 to 0 in the ice formation, there is expansion actually. होना क्या चाहिए था? Contraction, but हो क्या रहा है? Expansion. So your ice cube will expand in the ice tray. That's why it's stuck to the walls of the ice tray. That's why it is difficult to remove the ice cubes. Please guys, tell me that this thing is clear to you or not. There is no problem. We can give 10 minutes more to it, but the concept must be clear to you. Yeah, right. That is the main thing. That is the main thing. That is the main thing. Please tell me that this thing is clear to you or not, and I'll explain it. Great. दोनों को क्लियर है? No. Anushka, I do not calculate 4.4. I do not calculate it. It is the behavior of the water which is studied by the scientist. Okay, this is only the data which we have. Like, how can I calculate that the water is boiled at the 100 degrees Celsius? I cannot calculate it until unless I have to do experiment on it by putting the thermometer, by watching it. Okay, at what temperature it is going to boil. Like in the same way, they calculate the specific volume which is minimum at the 4.4 degrees Celsius. When the scientists measure the temperature, the temperature is basically 4.4. This is the case actually. Okay. Now, very good. Further, please, next heading will be saturation temperature. Please put the next heading, saturation temperature and saturation pressure. Saturation temperature and saturation pressure. Okay. What is this? Right? See, if I'll say that, see, in you can say in general language, or you can say that in routine life, you can say, or you can see in layman language, what we will call? We will call that boiling point of the water is 100 degrees Celsius. At the 100 degrees Celsius, water is going to convert it into the vapor. This is the incorrect statement, guys. This is not correct at all. No, this is not correct. If I'll change something, then you cannot boil it at even 120 degrees Celsius. Now, what is the correct statement? Correct statement is water boils at 100 degrees Celsius at 1 atm pressure, guys. Right? If you change the pressure, boiling point of the water will also change. Boiling point of the water also change if you change the pressure. So 100 degrees Celsius, this number is not universal. That every time water is boiled at the 100 degrees Celsius, no. Pressure should be 1 atm for that. It is clear to you or not? It means that if we increase the pressure by 500 kilopascal, then it do not boil at 100 degrees Celsius. It boils at approximately 152, or if I give you the exactly data, then it is 151.8, 152 degrees Celsius, guys. See, because there is a direct relation of the pressure and the temperature. Yes or no? This funda is clear to you? This funda is clear to you? Please tell me this funda is clear to you, guys? Okay. Very good. Then we can say that's why or you can say, we can say that the temperature at which water starts boiling depends upon the pressure. Therefore, if pressure is fixed, so is boiling point. If your pressure is fixed, then you can say, yeah, my boiling point is also fixed. Otherwise, you cannot say it. Okay. So we can say that, okay, I need one more slide, guys. Slide to explain all these things. The topic is very interesting, I must say. Yeah. Then I can say that very important, because saturation temperature, saturation pressure, these terminologies I will use again and again, right? So please pay attention. At a given temperature, boiling point stands for the pressure. So suppose let's write like this: at a given pressure, the temperature at which a pure substance change its phase is called saturation temperature. Saturation temperature, right? Noted by the T set. Likewise, this also we can call it for the pressure now, that at a given temperature, the pressure at which a pure substance changes phase is called saturation pressure, and it is denoted by P set. Please tell me that this funda is clear to you or not. So that now this has to be very clear that it is not necessary, or you can say boiling point for any substance is not fixed. It is totally depend upon the pressure. It is totally depend upon the pressure. If you change the pressure, boiling point will, you can say, change. Okay. Okay. Now, just to understand. So I talk two kind of energy here: sensible heat and pure latent heat, right? So I'll just explain these two energies. Sensible heat. Okay. So what is my sensible heat? My sensibility is the heat required to change the temperature of the pure substance, right? We can denote as QS, that is equal to MC P delta. This is the formula. So whatever you see the formula MCP delta T, that is for the sensible heat actually. That is the sensible heat actually. Okay. Please write all these things and let me know. Noted? Noted or not? Noted or not? Okay, see, so let me give you a very basic thing. I hope that you guys are uh, you can say that are aware about it, that all of you are aware about it, but still for my assurance, I'll explain each and everything, right? So because that not single student miss any information, right? So guys, tell me, when the solid is converted into the liquid, what you will call it? What you will call it? You will call it as melting. You will call it melting, right? When the liquid is converted into the solid, what it is? It is by freezing. It is called freezing, right? Okay, again, when the liquid is converted into the vapor, very simple, vaporization. Vaporization, right? Okay, vapor converted into the liquid, it is very simple, it is my condensation. It is my condensation, right? Okay, when the solid is converted into the vapor, direct, right? As we know that solid converted into the liquid and liquid converted into the vapor. But when the solid is directly converted into the vapor, then it is called sublimation. Then it is directly called sublimation. It is clear to you? And if your vapor is directly converted into the solid, then it is opposite to it, sublimation. It is my sublimation. So these are the very simple words. I must say that I can repeat. Okay. So we can say that during melting, during freezing, during vaporization, during condensation, during sublimation, temperature will constant. Right? Temperature will constant. Temperature remains constant during this process. During this process, right? I hope that it is clear to you. Can we move forward now? Can we move forward now? Please tell me, can we move forward now? So like sensible heat, another heat is there, that is called latent heat. That is called latent heat. Okay, please write it. Please write it. Done with this or not? done with this or not? Okay. Now, so latent heat, right? Latent heat means the heat utilizing to, I can write this, the definition that heat, okay, one thing, just by parts, I'll explain one by one. So there are some parts of the latent heat. First, I'll explain latent heat. Latent heat of vaporization. Right? Latent heat of vaporization means that what is the phase? Phase is my liquid to vapor. Yes or no? Liquid to vapor. This is the latent heat of vaporization. Yes or no? Right? It is clear to you or not? It is clear to you or not? Or latent heat of fusion. Latent heat of fusion. So that fusion wala heat is basically what? It is basically when the solid is converted into the liquid. Solid is converted into the liquid. Okay. So see, latent heat of fusion, what is that? See, amount of energy absorbed or released is latent heat. Okay, do one thing, just I should write like this. Amount of heat released or absorbed per unit mass for phase change. For phase change. Per unit mass, we have to vaporize, solidify or anything per unit mass. So that the heat released or the heat absorbed per unit mass for a phase change is called by latent heat. Right? So in the latent heat of fusion, if solid is converted into the liquid, it means that heat is being absorbed by the solid, right? It is clear to you. So I can write that amount of heat per unit mass needed for melting. Amount of heat per unit mass needed for the melting. That is called by latent heat of fusion. It is clear to you. See, just try to understand this point. Solid to liquid now. So this is my, where is my diagram? Okay, see. You can understand like this. This is my liquid. This is my liquid. And this much amount of heat I give to this system to convert it into the vapor. It is clear to you now, right? So the heat required to convert the liquid into the vapor, that is the latent heat of vaporization. Can we write this or can we understand this in opposite way also? That can we say that the same amount of heat is basically released during the condensation process. Yes or no? During the condensation process. In the condensation process, vapor gets converted into the liquid. Yes or no? So same amount of heat is released. It is clear to you or not? So the heat is absorbed by the liquid for the conversion into the vapor. That is called by latent heat of vaporization, because it is the heat has to be absorbed. and when the heat is released, same path process will follow the same path for reaching to the liquid state, and the same amount of heat is released by the system. It is clear to you or not? Please tell me. It is clear to you or not, right? So in this way I can say that this heat is same, or this heat is equivalent to amount of energy released during freezing. During freezing, right? Means so liquid to solid, the conversion between liquid to solid. Okay, and what is the latent heat of vaporization? It is very simple, that amount of heat absorbed per unit mass for vaporization. It is clear to you or not? And the same heat is basically released in the you can say the condensation process. It is clear to you or not? Okay, so if I talk about the amount, then let's suppose we have a 20 kg water or 30 kg water or anything, then how to calculate the total heat? So Q is the total amount of vaporization, that is whatever the mass, and this is my latent heat of vaporization, right? So we are talking about this LV. So what is the LV? LV is equal to total heat required for the vaporization divided by per unit mass. It is clear to you or not? It is clear to you or not? Similarly, the latent heat for the fusion is equal to total mass and into the latent heat of fusion. The latent heat of fusion. I hope that this thing is clear. I hope that this thing is clear to you guys. Done? This is clear to you or not? If you are going from solid to liquid, it means that heat is basically absorbed, and from liquid to solid heat is released, right? So here heat absorbed and here heat is released. Okay, in the same way, liquid to vapor heat is absorbed, from vapor to liquid heat is released. So you can say the Q for melting and Q for freezing by amount is same. Q for vaporization, Q for condensation by amount is same. Q for sublimation, Q for sublimation by amount is same. Okay? There is no need to this you can say going into the detail of all these things, right? I hope that all these things are clear. Okay. Now please put the heading property diagrams for phase change processes. Property diagrams for phase change processes. And this one is very, very, very important. This one is very, very, very important. So in this chapter, what we are going to do, we are going to understand the behavior of the water. Means according to the variation of the properties, how the water behaves. By changing temperature, pressure, how water behaves. By increasing pressure at constant temperature, by keeping pressure increase or temperature increase, decrease, what is the behavior of the water? All these things are basically we are studying in this chapter. Nothing else. Am I clear with this? Just try to understand this. This graph looks like very horrible. this graphs looks like very difficult, but just patience, just you should have some patience, guys. Give me only 5 minutes, I'll explain this whole diagram and you will never forget it. Now just understand it. So basically we are going to plot the TV, PV, PT diagrams. Okay, now first my task is to understand the TV diagram. Let's understand this. Let's understand this. Okay, see. This is very basic. You should know this. Generally, if I talk about the liquids, then density, what is the variation of the density? By increasing pressure or temperature. Let's suppose I'm increasing pressure or I'm increasing temperature. What you will see. Density formula is nothing but it is my mass upon volume. If you will increase the pressure, means you are doing the compression. In the compression, volume will decrease. If volume will decrease, my density will increase. Here also, as we increase the temperature, expansion will happen. In the expansion, volume will increase. If volume will increase, my density will decrease. Means for sure, when the pressure is, if my pressure is increased, temperature will also increase. For sure, it will increase. अगर आप pressure को increase करोगे तो temperature increase होगा. Let's suppose we are increasing the pressure. What is the effect on the density? Density will increase. And due to the increment of the pressure, my temperature is also increased. Due to this effect, my density will decrease. If I talk about the overall effect, what will be the overall effect? It will overall increase or it will decrease. So actually the pressure variation on the density of the liquid is very, very negligible. Means that the density will increase by 0.00001. But the temperature, due to the temperature, density will decrease by significant amount. So overall, we can say that density will overall decrease. Density overall will decrease. This is my overall result. This is for the liquid, guys. It is clear to you or not? But for the gases, it is different case. Opposite. If you will increase the pressure, what will happen? Now the significantly your density will decrease. Because you have a gas, you are increasing pressure, compression will happen, and volume will significantly decrease. Volume will decrease. Right? It is clear to you. So yeah, in the gas, in the gas, the density will decrease. And if we talk about the temperature, due to the temperature, density will increase. So overall, the density is basically increase. So just forget about all the things. In the liquids, by increasing temperature, density will decrease. For the gases, by increasing temperature, density will also increase. Density will also increase. It is clear to you? What it is? It is by increasing pressure, volume will decrease and density will increase. Yeah, density will increase. Density will increase here, right? And here also, the temperature will increase, density will increase. Overall, there is an increment in the density. This is the gaseous case. So density increase means specific volume increase, and density decrease means specific volume decrease. Now, I hope you remember this diagram. I already draw the TV diagram for a single pressure. I just already draw this diagram at 1 atm pressure. Now we will try to plot this diagram for different pressures. Forget about all things, guys. This is my pressure at 0.01 megapascal. So this is the line. Same line which we already discussed. Right? What are these points? These are the saturation points. These are the saturated liquid, and this is my saturated vapor. Let's suppose I'm increasing pressure. If you increase the pressure, temperature will also increase. So from here to here, temperature will also increase. So now my pressure is 0.1 megapascal. I increase the pressure, temperature will automatically increase. It means when the pressure will increase, my saturation temperature will also increase. These points are what? These points are basically representing the saturation temperature. It is clear to you? It is clear to you? At this specific pressure, the temperature at which the phase is going to change is called saturation temperature. So here my pressure is fixed, that is 0.1 megapascal. At this temperature, my phase is going to change. It means that this temperature is what? It is my saturation temperature. This corner is representing the saturated liquid side. And by increasing temperature, please pay attention, by increasing temperature, my specific volume will decrease. So here the temperature is low, and at the higher temperature, you can see that your specific volume will decrease. Right? It is clear to you? Now see, what I'll say, नहीं उल्टा उल्टा पढ़ दे, give me 1 second, उल्टा हमने कर दिया. Please see this. 1 by rho is my volume by mass, right? If your density overall will decrease, your specific volume will increase actually. So this will increase actually. This is opposite. Volume will increase. And here my volume will increase. Okay? Yes. I catch this point. आप लोगों ने पहले बताया नहीं मुझे. Right? So volume will increase. Specific volume will increase. So here just see, it means it is very simple that liquid side my volume will increase when we increase the pressure. Also by increasing pressure, saturation temperature will increase. Also my volume will increase. Which side? Liquid side. What about the gaseous side? When we increase the temperature, when we increase the pressure, saturation temperature will increase, but the volume, specific volume will decrease. So point. So at this pressure, these are the volumes. At this pressure, the volumes is basically going to decrease. Why? Because this side is representing the vapor side. Again it is decrease. Again is decrease. Again it is decrease. What about the liquid side? It is basically going to increase, 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 and increase. I hope that up to this point it is very clear to you. Please tell me, guys. Please tell me that it is clear to you or not. This is clear? Okay. It means that these points are going to be, you can say, if you will, this area will shrink. Well, means that this line is basically going to decrease. By increasing pressure, this line will decrease. By increasing pressure, the length of the line will decrease up to a certain point, up to a certain pressure. Both the points will merge at a one point. These two points actually merge at a single point, and that point is called my critical point. That point is my called critical point. At this critical point, the pressure is called critical pressure. Temperature is called critical temperature. Specific volume is called critical specific volume. And this point is very important. This shows a very, you can say, this can give us the very unique things, you can say unique information about the water. Okay, so for today's class, that's it from my side, guys. I'll explain it further. The next class we will explain it in a very, you can say, detail. Okay, I hope that you got every information. Just repeat this lecture, repeat this information. If you are unable to you can say understand anything, or if you missed anything, right? If you want to ask something based on it, you can ask. Okay. Okay, guys, then let's meet in the next class. Okay, bye bye, take care, thank you so much. मिलते हैं फिर next class में. Okay.